Okay, these are the notes for section 2.4. This is the second part of the notes. Now this one is writing a quadratic equation using 3 points. Now you're given on the first, this is the question number 5 on the notes. You're given a table with those numbers in it. Now to see if it's quadratic or not, you want to find the differences. The first one is called the first difference. What you do is go through and subtract the second one minus the first one every time. So 20.4 minus 19.1 is 1.3. Then 19.9 minus 20.4 is a negative 0.5. You can see that already these aren't matching. If you do the next one, you get a negative, you take 17.6 minus 19.9 is a negative 2.3. 13.5 minus 17.6 is negative 4.1. If those were all alike, this would be linear. They don't match, so it's not linear. Now to check and see if it's quadratic, we're going to find the second difference. Now we subtract those numbers. Well, 0.5 minus 1.3 is a negative 1.8. Negative 2.3 minus negative 0.5 is negative 1.8. Negative 4.1 minus negative 2.3 is a negative 1.8. Now notice now those second differences all match. That tells you that this is a quadratic. So that's how you can tell from the table if it's a quadratic or not. All right, now these are a little trickier to find. What you have to do is we're going to take those points and plug them into our equation. Now we're going to start with our standard form equation, which is y equals ax squared plus bx plus c. Now we're going to plug each one of those sets into here. We just need to plug 3 of them into there. Let's just say we go in order. We plug this first one. So if we plug this first one, that's the point 1, 19.1. So we're going to plug 1 in for all the x's and 19.1 in for the y. So we're going to start with 19.1 for y. Then 1 is going in for the x's. So 1 squared times a is a. Plug 1 in here. 1 times b is b. And then c stays the same. Do that with the second point, which is 2, 20.4. Again, we're putting 20.4 in for y. We're going to put 2 in for the x's. So 2 in here, b 2 squared is 4a. Put 2 here, b times 2 is 2b. And the c stays the same. Then one more time. Let's say we do it with 3, 19.9. So 19.9 goes in for y. 3 goes in for x. So 3 squared is 9a. B goes in, or 3 goes in for x here. It gives you 3b plus c. So now we have these 3 equations. Now this goes right back to what we did before with 3 equations and 3 variables. First, we want to get rid of one of the variables. Well, the c is pretty easy to get rid of. Like here, we could just take and subtract 2 of these equations. Like let's say we take these 2 equations here and subtract. I'm going to subtract the second one minus the first one. So 20.4 minus 19.1 is 1.3. 4a minus a is 3a. 2b minus b is 1b. And the c's cancel. Now pick another pair. Let's say, it doesn't matter. Let's say we take these 2 here and subtract. 19.9 minus 20.4 is a negative 0.5. 9a minus 4a is 5a. 3b minus 2b is 1b. So I got rid of c. Now I have 2 equations with 2 variables. Now we need to get rid of another variable. Well, now these line up pretty good because if I subtract these, I can get rid of b. So if I subtract, let's say I take 1.3 minus a negative 0.5, that's 1.8. 3a minus 5a is a negative 2a, and the b's cancel. Then divide both sides by a negative 2, so we get a is a negative 0.9. Now we need to find b. But take that a and plug it into one of these two equations up here. It doesn't matter. Let's say we put it in the top one. We'd have 1.3 equals 3 times that negative 0.9 plus b. Well, that's a negative 2.7. So if I add that to the other side, that gives me 4. So b equals 4. Then for c, we take both of those and plug it into one of the originals. Like let's say we plug it into this top one. We know 19.1 equals a, which is a negative 0.9, plus b, which is 4, plus c. Negative 0.9 plus 4 is a negative 0.5. So if I add 0.5 to the other side, I get 19. I'm sorry, I didn't add that correctly, excuse me. If I add those, I forgot this is not a decimal. So that's 4 and a negative 0.9 is 3.1. So if I subtract 3.1 from the other side, I get 16 for C. So now we found A, B, and C. So again, we plugged 3 of the points in for X and Y. Gave me 3 equations with 3 variables. Then we subtracted these first 2 to get rid of C. We subtracted the bottom 2 to get rid of C again. Now we had these 2 equations with A and B. It worked out good. I could just subtract to get rid of B. So we subtracted to get rid of B, and that gave us A. Once we found the value for A, we plugged it into one of these 2. I chose to do it in the top one and found out that B was 0.4. Then we take both of those and plug it into one of these. I just chose the top one and plugged it in there to find C. So now my equation is y equals A, which is a negative 0.9, x squared, plus B, which is 4x, plus C, which is 16. So that's the equation for that. It asks you to write a function to approximate the height after 6.5 seconds. What you would do then is plug 6.5 in for the 2 x's there and find out your answer. So if I did that on the graphing calculator, if I take, you can see that, if I take a negative 0.9 times 6.5 squared plus 4 times 6.5 plus 16, I get 3.975. So the height after 6.5 seconds would be 3.975 feet. All right? So that's the first example. Let's look at the second example. So this is problem number 6. Now again, here they gave us a table. If we look at that table, it starts with 0, 1, 2, 3. One thing I didn't mention on the other ones, it's important to see how they're all just 1 apart. Just like on the previous, they were all the same distance apart in the first column too. That's important. They all need to have the same gap between them also. So our numbers were 0, 180, 720, and 1620. So again, if we do the first difference, 180 minus 0 is 180. 720 minus 180 is 540. 1620 minus 720 is 900. So those aren't the same, so it's not linear. Second difference, subtract those. 540 minus 180 is 360. 900 minus 540 is 360. Since those are both the same, that tells you this is a quadratic. So that's how you tell that. Now, we need to take those 4 points for 0, 1, 2, and 3 and plug them into our equation. Again, we're starting with the standard form, which is y equals ax squared plus bx plus c. So that first point is 0, 0. So we're plugging 0 in for x and 0 in for y. So y is 0. Now if x is 0, 0 squared times a is just 0. 0 times b is 0, so all we have left is c. That worked out great. Our next point is 1, 180. So if we plug that in, again, 180 goes in for y. X is 1, so 1 squared times a is a. 1 times b is b. And we already know c has to be 0. We plug the next one in there. So it's 2, 720. So 720 goes in for y. 2 goes in for a. So 2 squared times a is 4a. 2 times b is 2b. And again, we already know c is 0. So this one works out great because now we only have 2 equations with 2 variables. We need to cancel out another variable. Well, what if we take this one times a negative 2? So if I multiply that by a negative 2, that'd be a negative 360 equals a negative 2a minus 2b. Now let's add these two together. That'll be 360. That'll be 2a. The b's cancel out. So we get a is 180. So now we know a and c. If we go to this, let's go to this equation and plug in. We have 180 equals a plus b. Well, if we subtract 180, b is also 0. So here, b is 0, c is 0. We only have an a. So if we plug that into our original equation, we're going to have y equals a x squared plus bx, which will be 0, plus c, which will be 0. So that's our equation right there. So if we want to find the same rope that's a circumference of 10 inches, we're just going to plug 10 in here. So 10 squared is 100. 100 times 180 is 180 and 2 zeros. So it'll be 18,000 pounds. Right? The next thing on here is using your calculator for this. So what you're going to do is, we've done this before, where we enter things in here. So we're going to use the stat function for our calculator. So we go to stat, edit. So I'm on edit, so I hit enter. Now, there's stuff in these columns. Remember, to get rid of that, if I move my cursor up to L2 and hit clear and enter, do the same with L1, put the cursor on L1, hit clear and enter. That'll get rid of anything that's in there. Now we're going to enter the numbers in from that table. So if we look at our table here, we're going to enter in all the miles per gallon. That's our x's. So 23, enter. 34, enter. 42, enter. 47, 50, 61, 72. Then go over to the second column. Enter those in. 17.1, 23.4, 27.5, 28.6, 29.6, 26.2, and 22. So enter those in there and hit enter after every one. So we enter the data in. So now it's all in. Now we want to use the calc thing. So we're going to press stat again, as you can see that. So you press stat again right here, and it takes you to this menu. We want calc, so use the right arrow to go over to calc. Now, if you look down there, see number 5. Number 5 says a quadratic regression. That's the one we want. So we press 5, and it'll put that on your screen, and hit enter. It'll find a quadratic regression for that. It'll tell you all of your numbers. So if you see those on there, that gives us what we need for our equation. So here, so on our y equals ax squared plus bx plus c, we're just going to plug those numbers in. So we have y equals, it says a is a negative 0.015 x squared. B is 1.55. I'm going to go one more at 4. That's for x. and then it says C is a negative 10.863. So it just gave us our quadratic equation there. So we just write them in. We just take those values right off your calculator. So you see where we got all those from? So there's our A, that goes for the x squared. There's our B, there's our C. Now we talked about this number before, R squared tells you how good of a correlation it is. Since that's pretty close to 1, this is a pretty good correlation if we graph that. Now here it asks you to find the optimal driving speed. You could graph that. We can also use our negative B over 2A, because the best driving speed, you see this has a negative A, so it's going to open down, so it has a maximum. So this opens down, so it has a max. The max is at x equals negative B over 2A. And that formula is very handy for these. So here, that'd be a negative 1.554 over 2 times a negative 0.015. If we do that on our calculator, that works out to 51.8. Now in this problem, x represents the miles per hour, so that is actually our answer, 51.8 miles per hour. So that's the optimal driving speed. That's roughly how they figured out, years ago, the speed you could drive was like 70 miles an hour in the day and 60 miles an hour at night. Well, back when we had the first gasoline shortage, they figured kind of optimum driving speed. That's where the 55 came from. They did data just like this. They evaluated the equation and they worked out to 55 was a kind of a compromise between good gas mileage and still being able to get there. So that's why the speed was 55 for a long time. And that does it for part 2.